Hi everyone, this is Dr. Vaughn, and I am going to make a quick video. Actually, it's my second attempt at making this video because the first one was almost 19 minutes long, and they'll only let me host about a 15-minute video max up on YouTube. So this time, instead of having you watch me type all of the stuff on the screen, I'm just going to talk about it with the answers already pre-populated onto this Word document. So the intent here is to give you a quick review of some factoring techniques, and I'll start with the technique number one. So this is the first one that you should always use in any kind of a factoring problem, is to look for the greatest common factor. So the example problem that I have here has all these S's and T's. It's kind of ugly looking, but that's all right. We just kind of, the first thing we do is always look and say, do these three terms have anything in common? And if so, I'm going to pull that out and then deal with whatever is left over if possible. So I treat each of these parts separately, and I'm looking first at the numbers, and then I'll look at the T's, and then I'll look at the S's. And I'm asking myself, what do they have in common? What's the greatest common factor of 18, 27, and 36? And the answer to that is 9. So I put 9 out in front. Now I look at the T's, T cubed, T, and T squared. What's the biggest thing that they have in common? And that's only going to be 1 T, because there's only 1 T here. And I look at the S's. What's the biggest that they have? What's the most that they have in common? The most they have in common is 1S, because after that 1S goes away, there's no more S's left here to be in common. So I find the greatest common factor, which is 9ST. Then I put in the parentheses, and I start pulling out the stuff. I look at what's the leftover after that goes away. So after 9 gets taken out of 18, I'll have 2 left over. After a T goes away from T cubed, I'll have T squared left over. And after the S goes away, I'll have nothing. No more S's left over. And the middle term, after 9 goes away, you have minus 3 left over. After the T goes away, there's no more T's. After one of the S's goes away, you have S cubed, and so forth. So you pull out the 9ST, you deal with the leftovers, dealing with the numbers, separate from the T's, separate from the S's. And at the very end, what you want to look at is this middle leftover stuff and say, is there anything else I can do with that? And in this case, there's not. So we're done. The next case that I wanted to review with you is factoring general trinomials with a leading coefficient of 1. So these are things that look like this. There's a variable squared, there's a copy of the variable, and then nothing with the variable. And there can be some numbers in front or over here or over here. In this case, we're only dealing with ones that start with a 1, which really shows up as nothing. It's not a 0 nothing, but it's there's you don't have to write 1x squared. You just write x squared, because 1 times anything is anything, right? So the way you factor these is using a guess and test kind of method. So you take this last number, the 18, and you write out what all the different kinds of factors are. So the ways I can multiply together two numbers, two whole numbers, to get 18. It's 1 and 18, 2 and 9, 3 and 6. And I'm going to try plugging in the 1 and 18, 2 and 9, 3 and 6 into these two slots over here until I can get the outside and the inside to add up to be this middle number, minus 7. Now, I wanted to say a word about the pluses and minuses, because when you're setting them up, this, filling in the blanks, how did I know to put a plus here and a minus there? Well, I don't really, except that when this number is minus, one has to be plus and one has to be minus. So I just put the plus first and the minus second. What I can switch, though, is whether the 9 goes in the first slot and the 2 goes in the second slot, or the 2 goes in the first slot and the 9 goes in the second slot, and so forth. So you just kind of play around with it. You plug in the 1 and the 18, and you say, okay, that would be minus 18, and plus 1 would be minus 17. That's too much. And you try every possibility. There's only 6 of them until you stumble upon the right answer. Minus 9m, and then plus 2m. Minus 9 plus 2 gives me the minus 7 that I'm looking for over here. If you get the signs wrong, it means you have the right numbers, but you put them in the wrong order when you have opposite signs like this. If this number is a plus, then they're either both pluses or both minuses, depending upon what this number is. Okay, so I gave you a 1 plus 1 minus case because this number is minus. But if this number is plus, they're either both pluses or both minuses, depending upon whether this is a plus or a minus. Okay, the third case is factoring trinomials where you don't have that 1 out in front. So this time I have an 8r squared plus 2r minus 15. Looks a lot like this, except for the presence of that number out in front. And we're going to play the same game, setting up the shell with the pluses or minuses, just like we did up here. But this time you have to put numbers in front of the r as well as putting them into the last slot in your factored form. So you have to play the same game that you did up here with the factors, but you have to do it for both the 8 and the 15. So the factors of 8 are 1 and 8 and 2 and 4, and the factors of 15 are 1 and 15 and 3 and 5. So I need to put the 1 and 8 or 2 or 4 into the first slots. I need to put the 1 and 15 and the 3 and 5 into the second slots. And you have to try all the different possibilities until you can get the outside and the inside to add up to be this middle number here. So again, I apologize for having the answer here. I think there's some value in kind of watching me figure it out and listening to me try some different possibilities, because you won't always get it right the first time. That's why it's called a guess and test kind of method. But after you try it for a while, you put the -5 over here and the 2 here, the 3 and the 4. So 2 and 4 are factors of 8, 3 and 5 are factors of 15. And when I take the outside numbers, 2 times -5, I get -10. And when I take the inside numbers, 3 and 4, I get 12. So plus 12 and -10. Plus 12 and -10 gives me the plus 2 that I'm looking for in the middle. The fourth case that I want to share with you is special patterns. These are ones that you have formulas for. And these are things you can write on a piece of paper, keep it next to your computer, look it up if you want to. But these are just kind of these general patterns of, this one's called the difference of two squares. And you have to just identify that I have a difference of two squares. One of the things that kind of tips it off for me here is I only have 2 terms. Whereas up here I had to have 3 terms to do either one of these other 2 things. And also there's no greatest common factor between these. So if step 1, 2, and 3 didn't work, then I'm either stuck, it doesn't factor, or it's got to be one of these special patterns. So I start thinking about that. So I take this special pattern, and the important thing to realize here is that A and B don't have to be like a single entity. It could be a whole bunch of stuff. Whole bunch of stuff squared minus whole bunch of stuff squared factors into this general pattern. So your task is really to kind of figure out what A and B is. And once you figure out A and B, then you just apply, you plug in A and B, and you factored it. So in this case, the A squared is going to be 36y squared. So what would A be? Well, 6y. 6 squared gives me 36. Y squared gives me y squared. And this one is the square root or 5z. So if A is 6y and B is 5z, then this expression represents A squared minus B squared. And I apply the pattern A plus B times A minus B. So A plus B, A minus B. And this is the completely factored version of the problem that I started with. The last example that I want to share with you is factoring by grouping, which is again a trinomial. And so it's something that we could kind of use this technique that we talked about up here in number 3, but it's an alternative way of doing it. Some people really like this way of doing it, and some people are really good guessers. If you're a good guesser, you can do this kind of technique, and you can do that kind of multiplication in your head that I was talking about. If you can't keep track of all that multiplication in your head, you might try this one instead, because what this does is it basically turns this problem into one of these kind of problems, which are a little easier. So in this case, what you do is you start with the 8 and the 5, and you multiply those together to get 40. Now you find the factors of 40, just like you did up here. 1 and 40, 2 and 20, 4 and 10, 5 and 8. And I want to find the numbers here that are going to add together to be this middle number. So the answer is 2 and 20. But that doesn't factor my problem for me. What that does is that 2 and 20 tells me how to split up the 22 so that I can factor using this technique called grouping. So I split the 22 into a 2 and a 20. 8x squared I had before, minus 2x minus 20x is the split version of 22, and then the plus 5 just stays the way that it was. But the whole idea now is to separate this into 2 parts, the first half and the second half, and to put grouping symbols in. So in order to put a grouping symbol on this latter half and leave a minus sign here, I actually have to switch this sign to a minus, so that the minus times the minus gives me a plus. Now you factor out the greatest common factor from each of the groups. The greatest common factor here is 2x, so I pull 2x out, and what you're left with is 4x minus 1. The greatest common factor here is 5, so when you pull a 5 out, you have 4x minus 1. it's really important that when you're doing factoring by grouping that the leftover stuff here in each of these two parts is exactly the same. If it's not exactly the same, factoring by grouping didn't work. When they are the same, 4x minus 1, then you can factor out that binomial, 4x minus 1, and look at just the leftover as being the other group. 4x minus 1 goes away, I have 2x left over. 4x minus 1 goes away, I have minus 5 left over. So 2x minus 5 times the factored out binomial 4x minus 1. You can FOIL this and you can check that when you do the outside and the inside, you'll get back up to what you had here. Okay, so this has been a very quick, very short review of some factoring techniques. I did also want to call your attention that there's a chart on page 462, which gives a much different version, not different, but it summarizes a step-by-step kind of process that you can think about when you're stuck with how do I factor something. Always start with greatest common factoring, like I said up above. Then look for special patterns. Then, if it's one of these, do this. If it's one of those, do that. And then the whole section of 6.5 is kind of practicing that decision criteria about which factoring technique to use. Because if you can just, by examining a problem, decide which factoring technique to use, then you can start to recall, okay, now I remember that, you're not guessing which way do I go about factoring it. You know which way to go about factoring it. Now you just have to execute that particular set of steps, which you can refresh yourself on if you wish. So I'm going to stop this video at this point so it doesn't get too long, and I hope that you've enjoyed this. If not, or if you'd like some additional instruction on any one of these kinds of topics, I'd be happy to do it. I do have to keep these videos short just for hosting on YouTube purposes. Have a great day.